In the last video, whenever I wrote a quantum number, or a set of quantum numbers, for example 1, 0, 0, 1/2, I had something off to the side that was orbital notation. So I drew a dash that represented the 1, 0, 0 part, so I called it 1s, and then I had an arrow to represent the electron, and since this is positive 1/2, it was an arrow pointed up. We're going to explore how to write these without having written the quantum numbers, because quantum numbers are very cumbersome. This orbital notation is a much, much easier way to figure out how to write where the electrons are. Difficulty with orbital notation is orbitals fill in what may seem a very not logical manner. The order of orbitals is not, let me do all the ones, then let me do all the twos, then let me do all the threes. It doesn't actually work like that. This is something called the Aufbau principle. The Aufbau principle essentially says electrons fill orbitals from the lowest energy to the highest energy. So what order do orbitals come in? Let me show you. What I'm going to show you is called a mnemonic. That is something to help you remember. Here's how you're going to write it. Now, it's very, very important to be neat here, or it's not going to show you what it is you want it to show. So you start with a 1s down here, and right above it 2s, 3s, 4s, 5s, 6s, 7s. That's pretty much all you need to do. You can actually keep going, but you pretty much run out of electrons in the known universe at this point, so you're okay. Next to the 2s, write 2p, 3p, 4p, 5p, 6p, 7p. Then, next to the 3p, 3d, 4d, 5d, 6d, 7d. Next to the 4d, you write 4f, 5f, 6f, 7f. Okay? Now, why isn't there anything down here? Well, remember, they don't exist. P means a quantum number of L equal to 1, but L can't equal 1 if N equals 1. So there's no such thing as a 1p. That's why all these guys down here are blank. Here's the mnemonic part, the part that's going to help you remember. Once you've drawn this grid, you want an arrow starting in the lower right and going up to the upper left, right there through the 1s. Then another arrow parallel to that through the 2s. Then another arrow parallel to that through the 2p and the 3s. Then an arrow parallel to that. And again. And again. And again. And some more. And of course the one after that would be the 8s. So you're pretty much done at this point. You're out of elements that anybody knows about. These arrows, is the order in which the orbitals fill. So first is the 1s, then it's the 2s, then following the arrows it's the 2p and then the 3s, then it's a 3p, then it's a 4s, then it's a 3d, then it's a 4p, then it's 5s, etc., etc., etc. So all you do is you just keep putting electrons in orbitals until you run out of electrons. Now, when you're doing this, you have something you have to remember, that every time there's an s, you only have one dash. Every time there's a p, though, there were 3 possible values of m sub l for L equals 1, -1, 0, and 1. So those 3 m sub l values translate to 3 dashes, if you will. 3 orbitals for the p level. D, remember, corresponded to an L equals 2. So there are 5 possible values of M sub L. -2, -1, 0, 1, and 2. So there are 5 different dashes here. F has 7 M sub L values, so there are 7 dashes here. And remember, the maximum number of electrons on each dash is 2. So the maximum number of electrons that can be in an S sublevel is 2. The maximum number of electrons that can be in a P sublevel is 6. The maximum number of electrons that can be in a D sublevel is 10. The maximum number of electrons that can be in an F sublevel is 14. So let's try this. Here I have my mnemonic to help me remember. Now let me pick an element. Let's start small. Let's go with carbon. Now I look at a periodic table and I see that carbon has 6 electrons. Okay, so the very first orbital I want is 1s. S's have 1 dash to them. So there's my 1s dash, and there are the 2 electrons, the m sub s positive 1/2, the m sub s negative 1/2, that are 1s. That's 2 electrons. I have 6 electrons, so I need to keep going. The next one after the 1s, according to my mnemonic, is 2s. So here's 2s. And I can put 2 electrons in there. That's 2, 4. I still have 2 electrons to go. So the next one, according to my mnemonic, 1s, then 2s, then the next one is 2p. So I'm going to write 2p. There are 3 dashes associated with 2p. So I have to write all 3, even though they're not all going to get filled. Now I have 1, 2, 3, 4 electrons. I need 6, so I have 2 more electrons to put in. Remember Hund's rule. Hund's rule says I can't pair them until there are no more quote-unquote seats left on the bus. Okay? So 1 goes here, and 1 goes there. Now I have 1, 2, 3, 4, 5, 6 electrons. That is the orbital notation for carbon. Let's try another. Let's try chlorine. That's more. This one's 17 electrons. Okay. So once again, I'm going to start with 1s, and then 2s. Here's my 2p. I'm going to fill this one this time. 1, 2, 3, 4, 5, 6. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 electrons. I still got 7 to go. So after the 2p comes the 3s. So there's the 3s. 1, 2, 2, 4, 6, 8, 10, 12. I'm still not done. I have 17. So after the 3s comes the 3p. 1, 2, 3. 3p. So let's see. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17. That is the orbital notation for chlorine. And you just do them all like that. You just keep going. You just keep filling in. Remembering Hund's rule as you go. Just keep following the pattern. Every time there's a P, you write 3 dashes. Every time there's a D, you write 5 dashes. Every time there's an F, you write 7 dashes. And you just keep going until you run out of electrons.